All right, good evening, everyone. This is the second lecture for Intro to Android. I'm glad that you guys are all still here. Uh, so, before we get started, there is an attendance form, so just fill this out. We'll give you like 2 minutes for this.
I showed it to him the second I was. Does everybody go to the attendance form?
All right. So, just a few announcements. So homework 1 was due yesterday. So hopefully you guys all submitted that. Other things, make sure to take this class as pass fail. If you're not enrolled, let us know. We can help you guys out. Homework 2 will be released after this class. It will be due on the 2nd of October. What date is that? Sunday? Okay. I'll be due on a Sunday. Make sure you guys want to try to fully complete this because homework 3 will be an extension of homework 2. So if your homework 2 doesn't work, it's going to be very, very difficult for you guys to complete homework 3. Also, if you need any help, make sure to post anything on Ed. We'll try to answer as much as possible and as swiftly as possible. So, yes.
Could you switch to the attendance form real quick?
Yeah, of course. Good?
Yeah, got it. Thank you.
Nice. I am slightly sick, so won't be as energetic as always. So today we'll be learning about view groups. View groups are a special way in order to contain all of your elements within your screen. So kind of went over this last week when we were talking about constraint layouts. They're a way to be able to organize all the things that you have on screen in a manner that you want. So constraint view is this thing that is most frequently used now. It is the default layout and is almost everyone uses it. It's very, very easy. It's efficient and it's quite powerful. Most of the other layouts that we'll be teaching or I will be teaching you guys are kind of deprecated. They're not used as frequently, but there are some special cases where you would want to use them over constraint view. But as a general rule of thumb, constraint layout is the way to go because of how easy it is and how efficient it is to use. Here's a little demo. We already went over how to use it last week in our demos, but the way it works is you take your item, let's just say it's a button, and you constrain the north, south, east, and west compartments of it to another component of the screen. So it could be the edge of the screen, it could be another component, right? The whole idea is you want to constrain all 4 of them, and then you slide the biases along so that you can get it to the exact location you want. Next thing there is called linear layout. All this does is just as it sounds, it's linear. It either assigns all of the items, all the children in this case, in a single direction, either vertically or horizontally. So that would look like this. So here, all your items are layered horizontally or they're vertically, right? This would probably be used, this most likely be used when you're doing something similar to a list. Yeah. Now, relative view. What this does is it basically puts a child relative to something else. So it could be to the right of blank, to the left of blank. So if I want something to the left of a button, right, I can use this. As I said, these layouts are pretty deprecated because you can do the same thing and more with constraint layouts. But there are perhaps some reasons to use this one. It is also quite expensive to use. So normally we always use constraint layout. Now we'll get on to inputs, right? For inputs, Android has a lot of inputs. They are ways for the user to interact with our UI There are ways for the user to interact with the screen, such as having a button, an edit view, like a bar that you can drag and drop, a switch, like a checklist, any of these sorts, any of all these. They're all inputs that you can put in, but hold up. So I'm pretty sure most of these are pretty self-explanatory. You just click it and it works. You guys have used this all the time, as you guys all have phones. So one of the things that you might not have seen a lot are seek bars. So the thing that's special about seek bars are that they're very, very useful user interface things. There's a lot of customability to it. So you can change the way it looks. You can change how it scrolls, change the icon, you can change the style, you can change the animation. And the way it works, it's similar to your volume settings, where you can touch and you can drag it along with your thumb and set the progress of these bars. So it enables a lot more what's the word? A lot more granular input from the user. Instead of just a single yes or no, on and off, you can select a range. So, for example, if you want to select a range of colors from like really light to really dark, you can use the slider to select from not just white or black, but from the entire spectrum of colors. So one of the things that we did that we have to use with these are called event listeners. What they do is they listen to the inputs that we just looked at. So last week, when we were doing the demos, I told you about XML. XML is the look of the entire screen. With XML, that's it. It is just the look. In order to actually make it so that when you press a button, it actually does something, you need an event listener, right? And there are a lot of different events. It could be on button pressed. What that does is when the button is pressed, it does something. It could be like these, add text change. It's pretty self-explanatory based on the name. It's when you input something or you change the text in the text field, it will activate this listener, right? On seek bar change, when the bar that you change, when you make this bar change, it will activate and it will do some sort of function that you want it to do. And all of this is actually coded in Kotlin. So that is the other file that we worked with, which is, as I stated before, the logic of your entire Android, Android app. So here is generally how it will work. So let's just, for example, last week we built a button. With a button, we call it my button, right? And you can make it so that within the public thing, you do a set on-click listener. All this does is it tells the button, hey, I'm making an on-click listener, and when it is clicked, I want you to do whatever's within these brackets or these braces, right? For this, for example, you can say when I press the button, I change the color of my text, I change the color of my button, right? It can do all of these things, and so the listener will always listen to it, and it will keep on repeating these events. So this is just and as a result, when you look at your actual Kotlin file, what you will notice is that your code does not execute sequentially, right? Like most of your other code, like let's just say, for example, Java, you put it in your main file and it will execute line by line. But what these lines do is it will always be happening, and it is just to tell you guys that when you're writing Kotlin, the file, it does not execute sequentially, and these functions will perpetually be happening in the background. And so once you call this, it will always be happening in the background. Now for an example. So this is from demo 1, right? We made a button. We made an on-click listener. So as we're repeating this, when you click it, it does something. Here, what does it do? Well, we look at it. It says val current text colon string edit text dot toString. So what it does is the text from your what's it called edit text is getting put into this current val, and then you set the text view into the current text that you inputted, right? So when the button is pressed, we convert the text that you typed in into the text that is shown as a text view on the screen. Now, after all this, one of the most important things about this class, and I think in general when it comes to coding, is just to read documentation and how to actually do research online. Because a lot of the times, if you want to add something else, if you want to do something, we can't cover every single input on the screen. We can't teach you about every single layout, right? With our input, for example, I gave only 6 examples. There are hundreds of them, right? And in addition, we're giving you an overview of how these inputs work. With an input, it is you have an input, you have on-click listeners, but there could be many different types, right? For example, with a button, it could be an on-click button, but if it's a switch, maybe you want it so that when it's on, when it's off, you want to do something special, and when it's on, you want it to do something special, right? So there are a lot more granular choices that we cannot cover in this course, and as a result, it is up to you guys to actually be able to understand the documentation and the API on Android Studio in order to understand what is going on. And as a result, you don't have to ask us as many questions, and you can get the instant feedback that you need. Also, another great thing is that Android does have a lot of documentation, so maybe the API is not your favorite thing. You can always Google something, as there will be a lot of examples online to showcase how to do it. Just keep in mind that sometimes a lot of the older documentation is in Java instead of Kotlin, which will make it slightly more difficult to read. So just make sure that you either switch to the Kotlin version to be able to actually understand it, because we are writing in Kotlin, or you can try to interpret their Java, and then rewrite it into Kotlin. There is a function where you can paste in Java code, and the IDE will try to do its best to convert it to Kotlin. And this will work for small blocks of code. However, if you just try to copy an entire block of code, I cannot guarantee that will work. So these are just little tips. So let's actually get into reading documentation by itself. So for our example here, we're looking at colors. Yes, we're looking at colors. The way colors works is it's very simple. It is just an object that represents a color. So this will be part of your homework too. So here we look. I just say the way a color is represented is it is normally represented with an RGB value, right? However, maybe you want to convert some ints. In this case, the HSV, which are hue, saturation, val. So I don't know if everyone knows this. There's another way to represent color other than RGB. RGB is just like 3 digits that represent numbers for the red, blue, and green. What's it called? HSV is another way with hue, saturation, val. It's the same idea. So for this, if you look at it, it's pretty self-explanatory. You have name. Okay, I like that. You read convert HSV component to the color, and the input here is a array of floats, right? So, and it tells you exactly what you want in the array, and as a result, it will return an int representing the RGB color. Right. So to implement it, all you have to do is put it in here. Remember, if it is a function, right? It is a function being called by an object. So first of all, you have to create the color object. Afterwards, with the color object, it now has access to all of these functions here that's listed here, right? with this, I have the array, and then I set it equal to a val, and boom, I get the colors. So now, for example, you need the array. How do we create the array for this as the input? The way it works is there's this function called float array. That just makes float arrays. You set the size equal to 3, and then what you do. So for this example here, we are getting the this is from homework 2, right?
Mm-hmm.
Yeah. So this is an example from homework 2. A little sneak peek into how to actually do it. Here, the values from seek bar. So imagine in homework 2, I know you guys haven't actually seen it, but we're trying to change the color of, I think, a box, and we will have 3 seek bars, right? Each representing the shifter for the exact amount of H, S, and V that you want to change. All right. And so as you shift it, it changes the H, S, and V, right? So that's what this seek bar hue.progress.toFloat does, right? This turns the progress bar. So imagine if this is the progress bar. If it's here, it's 50%. If it's here, it's like 100%, right? And I will change, as you change it, this will report back the percentage or whatever number that you set it to as the quote unquote progress, right? And then, so for the seek bar, for this one right here, the max value is 360, so you can just set the value directly to 0. But for 1 and 2, we had it so that the max progress is 100, and because the input only wants 0 to 1, we have to divide it by 100. Next, RGB. This is just, it returns a color int from red, green, blue floats from range 0 to 1. If the component's out of range, I feel like this is another pretty self-explanatory method. You just put in floats and it gets you the actual RGB color. To be honest, you don't actually even need this function. You can just put this into like an online thing, but there it is. So here we have the same thing. We have color.rgb. That is the object calling the function. Now, what is this one? Color to HSV. Same thing. Huh? Oh, okay, my bad. I wasn't reading this. All right. So, you might notice from this one. Sorry, my bad. You might notice from this one that there is no return value. It's public static void. It is not returning anything. This is because it actually puts all the values into the float array, right? So what this does is it turns the color to the HSV. So you input a color. You input the color as the RGB values. That's a hexadecimal. And then what it does is it then translates that into the HSV, and then it puts it into an array. Any questions? Because that is it for this lecture.
Anything before we move on to a short demo?
Yeah.
Okay, in that case, I'd like to point out one quick thing in the slides. So you'll see how in any of these color functions, you'll see that it's returning actually an int, which might be a little bit confusing. Like, I want a color. Why am I returning an int to represent that color? Well, the colors are actually represented. I think it was on one of these slides. For example, here, alpha is set to 0xff. It's some weird bit manipulation thing with the integers going on, and it would it would look like 0xFF, where FF is, say, the alpha, and then maybe if you wanted, if you had the color white, it would look like FF, also afterwards. So don't worry too much about the bit stuff. You shouldn't have to work with bit manipulation here. But if you do see that it's returning an int, just know that instead of like a really int, it's more of like an int representation of a color. So don't be alarmed when you see the int. That is a correct representation of the color. Okay, and going to our demo, let me pull up Android Studio really quickly. So we're going to just be starting off with an empty activity here. If you'd like to follow along, you can pull up Android Studio and follow with the demo. Of course, we'll have a more on your own thing on Wednesday at our discussion time. But since this is lecture, I will be going through this and pretty quickly. And so if you are falling behind, please let me know. Or, yeah. Project. It's just loading up. We have about 25 minutes maximum for this demo. I'll try to get through as much as I can. I think it should be enough time, but if not, we will save some of the implementation for discussion. So. Come on, Gradle. There we go. Almost done. Yeah, if you are following along, you can just open up an empty activity. That will suffice. Or an empty project, I should say. Okay, awesome. So now we have our activity here. And as you can see, as mentioned in the slides earlier, we have a constraint layout as default as our layout for our main activity. And obviously, constraint layout is the sort of default layout. It is the most recommended layout, and it's very flexible. And so we will be using that in our demo today. So the main sort of thing I want to make here is like a calculator for some, I guess, recursive functions. Don't worry too much about the recursive part. I just wanted to throw that in there because it sounds cool. But yeah, mainly we'll be using buttons to take an input, and then other buttons to say calculate the input for some input X, or like input from a text. And so how should I structure this? Let's see. Let's just start out with the text view on top. And let's name this to like just sort of have like a header for our app. As you can see with the constraint layout, let me zoom in here a little bit. We have these little nodes here that we have to drag along to the side and connect to parts of our view. So these can go either to the layout or to other views. And I'm not sure why it's so small. Oops, not that. Wrap content. Squishing it in there. Okay, there we go. Oh no, that's fine. Thank you. Okay, so we will add constraints